On March 23, 2012, NASA Mission Control told the crew of the International Space Station in space on the radio that a lot of micrometeorites are going to collide with the ISS 6 minutes. This radio message made a ruckus in the entire ISS. The astronauts had so little time that they could not even change the direction of the space station during this time. But the question is that in the part of space where the ISS is present, there are countless micrometeorites. So how does the International Space Station, ISS, survive these meteorites? How is this work done without fuel and without Earth to change the direction of the weighty ISS of 38 vehicles? How was a football field-sized ISS taken from Earth to space? And when the ISS is on the other side of the Earth, how is it contacted? Hello friends, you are watching Fact Galaxy, where we bring you real and heart-touching stories. If you enjoy this story, don't forget to subscribe our channel and hit the bell icon so you never miss a new story. Viewers, the $150 billion worth house in the ISS is a house whose example is not found anywhere in history. Hundreds of high-tech parts have been installed to make it. There are 16 pressurized modules in it, which include different modules for living and sleeping, different modules for an observation deck, and different modules for 6 science labs, which are all connected to each other through an airtight tunnel. In addition to these, many spots in the ISS are still empty. To park some extra capsules, some of the ISS lifeboats are parked forever, so that if there is an emergency, these lifeboats can safely take the astronauts to Earth. The International Space Station is the largest space station ever built. An ISS as big as a football field may be 400 km away from the ground, but it can still be seen from the ground with the help of binoculars. The total weight of the ISS, 460,000 kg. This is the same weight as that of 380 cars or 25 passenger buses. But the question is, how did such a heavy and large ISS go into space? The ISS began with just 2 modules, and they were both connected to each other in space. One module was made by the United States and the other by Russia. After the collapse of the Soviet Union in 1992, the United States and Russia collaborated, and the 2 superpowers decided to build an international space station in space. First, Russia sent a module named Zarya into space, and then the United States sent its Unity behind it. Flying at a speed of 27,000 km per hour, Unity followed Zarya. On November 20, 1998, at 6:40 a.m., these 2 modules were connected to each other 400 km above the ground, and this is how the International Space Station was born. Since then, over the past 26 years, engineers from all over the world have worked together to build their own modules and sent them into space through rockets and connected them to the ISS. Today, other than the United States and Russia, European and Japanese modules are also connected to the International Space Station. From the year 2000 to today, no day in the ISS passed in 24 years in which it has been empty. At all times, astronauts from any country are present in it. To meet the needs of astronauts in the ISS, all the facilities are available which should be in any superstructure, in which oxygen is the most important. A person can live for 3 weeks without food, 3 days without water, and only 3 minutes without oxygen. 400 km above the ground, where there is no atmosphere or oxygen to breathe, the biggest challenge for the ISS is to provide astronauts with fresh oxygen. An average person needs 15,000 liters or 22 kg of oxygen per day. For 9 astronauts living in the ISS, 200 kg of oxygen per day is really a big challenge. Here, oxygen supply for astronauts for many days is present in the tanks, so that if the system fails, the oxygen supply is enough for the astronauts to survive till the help comes from Earth. Today, technology has become so advanced that oxygen supply can be delivered from Earth to the ISS in just 6 hours. But only if the rocket launch is successful in that condition. This method is good, but it is very costly, because a cargo rocket costs $200 million to go from Earth to the ISS. Food and other supplies are sent once in many months. But it is very difficult to use rockets again and again to meet the oxygen demands of 200 kg per day. That's why the ISS makes its own oxygen without dependency on Earth. It has a small machine that makes oxygen by using water. When electricity is passed through water, it breaks into 2 parts, hydrogen and oxygen. Hydrogen and oxygen. Hydrogen gas bubbles accumulate on the positive electrode and oxygen gas bubbles accumulate on the negative electrode. Now, if this experiment is done on Earth, these bubbles automatically separate from the water, because it is obvious that the weight of the gas is less than that of the water. But there is no gravity in space. The weight of the water is equal to that of the gas, almost zero. So now, to separate the oxygen gas from the water, this machine is rotated in a circle, which creates a centrifugal force which acts as an artificial gravity. Due to the rotation of the circle, the water goes to the sides and oxygen gas is left in the middle, which the machine collects and puts in the container. Now here you must be thinking that if oxygen is made from water in the ISS, then where does the water come from in space? Here too, the magnificent engineering shows its magic. In the same process, the hydrogen gas that comes out is reacted with the carbon dioxide gas that comes out of the astronaut's breath, and water is made again. And in the end, methane gas is left, which is wasted in space. It is a very big challenge in itself to make oxygen for the International Space Station. But the bigger challenge is to keep this oxygen safe, because if there is even a small leak in the space station, the result can be quite terrible. In just a second, the space station will burst into pieces. The example of the recently destroyed Titan submersible is in front of us all. There is more pressure in the sea, while there was controlled pressure in Titan. As soon as its solution leaked, the sea pressure compressed it badly in less than a second. But in space, the opposite happens. Here the outer pressure is zero, while the pressure inside the IS is maintained. Just like Titan, if there is even a small crack in it, it will decompress and burst. The altitude at which the ISS orbits the Earth, there is a lot of space debris here, which is rotating very fast in space. These include satellite parts and hundreds of small and large meteorites. So the question arises, how does the ISS protect itself from these meteorites? The International Space Station is orbiting the Earth at a speed of 27,000 km per hour. It is so fast that if it flies at a speed close to that of the Earth, it can cross the Pacific Ocean in just 25 minutes. The same Pacific Ocean, which takes commercial planes 13 hours to cross. If it collides with a meteorite as small as a grain of sand at such a high speed, it will be like a car colliding with a tree at the speed of 80. On March 23, 2012, NASA Mission Control radioed the ISS crew that some space debris was heading straight for the ISS. No one knew how big this debris was. They were told just 6 minutes ago. The whole crew immediately went to the lifeboats, but fortunately, the space debris passed by the ISS without touching it. But the ISS can't always rely on fate against meteorites. In order to protect itself from small debris, the ISS was made of bulletproof material. Just as bulletproof vests have different layers, the ISS was also made by combining different layers. The outermost layer is made of aluminum, followed by a layer of woven material, and a layer of aluminum inside it again. A single metal is not as strong as cutting the same metal and spreading it in 2 or more layers. Micrometeorites like grains of sand are attacking the ISS at all times. But these are its bulletproof layers that have protected the ISS for the past 26 years. But what if a big meteorite comes in the way of the ISS? Not as big as the size of the car, but only 1 inch bigger. In this case, the bulletproofing of the ISS will not work at all if it collides at this speed. The mission control crew on the ground already has an idea of the location and position of the upcoming meteorites. If this seems like a loss, then the entire ISS has to be removed from the way. Small thrusters in the ISS can be used to change its trajectory. But these thrusters run on rocket fuel, and this fuel is very little with the ISS, only for emergency purposes. To end the dependency on the Earth of the ISS, a mechanism has been installed in it which can easily change the direction of the 460,000 kg weighty ISS without using rocket fuel. There are small boxes in its center which are called control moment gyroscopes or CMGs. But how do they change the direction of the big ISS like a football field? There are flywheels in these boxes which spin at a speed of 6,600 RPM. Flywheels are like heavy round wheels, just like train wheels. When they are spun at high speed, angular momentum is generated in it. This momentum is transferred to the entire body of the ISS, and thus the entire ISS starts moving in one direction. If the flywheel is spinning very fast, then the direction of the ISS will change a lot. And the direction in which it is spinning, the ISS will also spin in the same direction. If the ISS is spin in the opposite direction, then the flywheel is also spun in the opposite direction. These flywheels are rotated with the help of electricity, which generates the solar panels in the ISS. Speaking of solar panels, let me tell you that these solar panels are movable, because the ISS is orbiting the Earth so fast that the sun rises here 16 times a day. And even when the sun is there, it shifts its position so fast that if the solar panels are fixed, they will not get direct sunlight and they will not produce electricity properly. That is why these solar panels always keep their direction towards the sun. The solar panels in the ISS produce 120 kilowatt electricity at a time. This is the amount of electricity with which we can easily run 110 air conditioners on Earth. Keeping in touch with astronauts at the International Space Station was also a big challenge for mission control. Communication is through radio signals. These signals cannot cross the Earth, and often the ISS crosses the Earth. To solve this problem, the first aircraft was flown, which caught the radio signals of the ISS and took it to mission control in Houston. This method was costly and also very unreliable. Often the contact with the ISS was disconnected for up to an hour, until it reorbited the Earth and reached the range of mission control. But now this does not happen. With the advancement of technology and the help of high Earth orbiting satellites, the problem of communication has now been solved forever. Whenever the ISS to contact mission control, the first signal is caught by the satellite, then the same signal is sent to the satellite's network, and then whatever satellite is in the range, it relays the signal to Houston Mission Control. In this way, now with just a few seconds of delay, astronauts in the ISS can easily connect with their families. Scientists around the world have been trying to make the ISS self-sufficient for the past 26 years. A space station that needs Earth as little as possible. Many inventions have been made for this purpose, but there are still many requirements that need Earth's help to meet, such as food, chemicals, spare parts, and crew shifting to filter water, because an astronaut cannot stay in space for more than 8 months. There are many labs at the International Space Station for different types of experiments, most of which are done on the human body. The only purpose is that when humans go to Mars or deep space, they may have to face various difficulties. The ISS is only 6 hours away from Earth, but when humans go to Mars, there will be no support from Earth, nor will the way back be so easy. Once again, I request you to subscribe to the channel and share the video with other people so that the reach of our channel increases and we get the motivation to make more such videos. See you in the next video with another interesting topic. Take care of yourself.